Oh, thank you. So we will not be needing the invoice ID. Just these are just unique value to trace transactions. Then let's start with the branch. Data dot branches. We have for branch A, we have 340, 332, and 328. So let's check for the city as well. You can see we have 340, 332, 320. Definitely, A is representing this branch, B is representing this branch, then C is representing this NEI, PT, something, something. So we need to drop one of them. So, and I need to rename this city to someone we are all familiar with. So that would be data.city dot replace. Then I'm going to put this. And then what give us the like a city we can make use of instead of what we have here.
Lagos.
Oh yeah.
Okay.
Akwa Ibom.
Let's make use of Ibadan instead of Oyo.
Akwa Ibom. This is state. This is city.
Seems
Uyo.
you are racist.
Not the right things.
Like this. So we need to put in place equals to true. So we now check our data. You can see that those things has been replaced by our new column, except this Mandali. So we need to what is happening. Okay, I didn't change this. I wanted to change to Ibadan. So you can see now we have Lagos, Ibadan, and Akwa Ibom. Then we can drop this branch data.drop branch. Axis equals to 1. Then in place is true. Then we check again to be very sure. Data.
So it's not Akwa Ibom, it's Akwa Ibom.
Okay. Like this.
Yes.
Okay. So we dropped the branch column. Then we can move on to branch not found. We dropped it already actually. So there are a lot of other things we will drop. Let's check from here. We drop the invoice ID, then we drop the branch ID. We drop the invoice ID, we are going to drop the branch. Then if you look closely, if you see this tax 5% and this gross income, you can see that the two of them, they have the same value from the beginning to the end. This 3.820, 3.820, 16.215, then the same thing here. So we need to drop one of them. So I'm going to drop the tax 5% here. I will try run the income from the beginning. So here now I'll be dropping a list of column. Invoice ID, then tax 5%. So those are the ones that I think we don't need for now. And you can check the data to be sure that they've been dropped. So you can see that we don't have the invoice ID again. Then we don't have the tax 5%. Then we don't have the branch as well. So the next thing, let's check another column we can check with customer type, df.customer type. we can be plotting our data as we are doing it. Df dot branch dot city sns dot count plot and df dot city. So this will give us the count. I'm used to this df. Voila. Data. So you can see Lagos, Akwa Ibom, Ibadan. Then another thing is df dot sns dot count plot and data dot customer type. I've even started the visualization before. Let's keep this till we get to visualization. Then the next thing we should check for missing value. Data dot is null. We know that there's no non-value here. Dot sum. I use this to check the percentage. Df dot shape. Then the first one, which is the number of observations we have. It's like I will go back to using df as the name of my data frame. So we are very sure that we don't have any non-value. So we can try to do some feature engineering. Data.h. Let's see if we can generate more new features from our data set. We have the time, we have the date. Okay. We have the date now. We can generate the year and the month of the transaction. That's good. So let's just check data dot ed dot today time. Then we put in the column we want to change to date time. Data dot date. We run it before we assign it to variable. You see that it has changed to date time. Then we can now assign it to a new variable, to the previous variable, data and date. We are changing it. What we have initially, we are changing it to the date type. And we have, and from there we can generate year, data dot. I need to import datetime, import datetime as DT. Then data year. This is telling us that in the data set that I named data, I want to create a new variable named year. Then what I want to be inside it is equals to this my new data set that I've converted to datetime. Then I want to extract dot dt dot year. Then we can check data dot. Let's run it first. So we can now check if we have the new column. So you can see that we have the year column now attached to it. Then we can also create the month column as well, the same format like we did for this. Instead of dt.year, this one will be month. And will be dot month. Let's do the same thing for day. And dt date. Then this one will be dot day. So I want us to change our day to Monday, Tuesday, Wednesday instead of 1 to 3. Let's check what we have. Data dot head. So we have this day. Want from okay. I want us to change the months from 1 to January. That will take time. What can we change? Okay. If you are changing this 1 to 12, it will take time. Let's just leave it as it is. So we are done with the dates column. That's feature engineering. Feature engineering basically it is, for example, initially all we have is from this city to the rating. Then we generated this new column, year, month, day. Then we can check out which of the months has the highest sales and some other things like that. So let's go to data visualizations. Data.columns. So I'll be checking the column to know exactly what column I need to work on. We can start with sns.count plots. We did that already for city. We are doing it for customer type now. Customer type. Then
Sir,
you said what?
sir, please can you slow down a bit? I think you're a bit
And also
fast.
comment on this thing someone.
And maybe we'll get to comment also.
Okay.
Thank you, sir.
I have a comment already. This is data visualizations. Then yeah,
Okay.
the one we did initially is data engineering. We generate new data, new variables from our
Yes, sir.
initial data set. Then this is count plot. We want to count the number of different types of customer we have. Then my data equals to, what will my data be here? My data will be equals to what?
Um, it's
Maybe payment.
supposed to be the.
Hmm?
Did you unmute?
Hello? Anyone?
Equals data,
Why did you say that?
because that's the name of our data set.
Exactly. Our data equals the data. Thank you. So we can see the member, the normal member, they are about 500. Those that are member, this one are people that are like, they have a kind of subscription, they are registered member. Then we have the normal people that just come and go, they are not registered. So they are almost the same thing. If you want to get their exact number, just you can do value count, df
Is it DF or data?
data. Thank you. I'm used to the df of a thing. I'm used to it. It's data. Df means data frame. Dot value count. So you can see they are so close. For the member we have 501, for the normal we have 499. So another thing we should talk about is group by. Data dot group by.
It's unmuted now. Sir,
Oh, city.
but we can just do data dot customer type dot what's that thing
It's
called? Value
it
count, and to
can
give us the same thing, right?
no, it can't work because there is a space between these. I talked about it, I think yesterday.
Oh
You
yeah,
see there,
true.
you see there is a space between customer and type. It won't work that way.
Okay,
So
sir.
if you want to do it that way, it's better we rename our data frame from we rename the columns from the beginning. Everyone that has the space, we try to remove the space. So this we want to group our data set by city. Let me name it city data. Then city data dot mean. This will group our data set by the city. You can see that the mean unit price in Akwa Ibom is this, then for Ibadan, then for Lagos. The same thing for quantity, the same thing for gross margin, percentage, the gross income, then the rating, the year, the month, and the same thing for the day. So another there is a U parameter in Cbon. It is very good. For example, we want to know the number of male customer we have in a particular city. That would be SNS dot count plots. Then we put in gender. We put in the E parameter equals to, or E is supposed to equals to gender. city. And we have the U parameter as gender. Then our data equals to data. What do we use for gender?
So what's the meaning of hue? Hue.
That's what I want to explain. Okay, the gender is capital G. The U parameter is a kind of group by. We want to count the number of customer based on their city. Then we want to group them by gender. We want male gender to be separate, female gender to be separate. So we have the counts now. For Lagos, we have about 150 something. You can see the blue one is for female gender. Then we have about, this is telling us that we have more more male more male customer in Lagos. For example, in Akwa Ibom, we have more female customer. Then for in Ibadan, we have more male customer in Ibadan and Lagos. But in Akwa Ibom, more female. So the EU parameter is like we try to group it by gender. And then we can do some other things as well. SNS dots, box plots. We can see who spend more, male or female. Does anyone have an assumption like who will spend most?
Female.
Female, okay. Females, do you agree? Hello? Okay, it's like they are okay with that. So this is the box plot. Is this total? Total variable. SNS dot count plots. Total. Why don't we have the gender here? Let me try to remove the U parameter first. So you still have the same thing. So I need to specify my x-axis to be my y equals to total, then the x-axis will be for gender. So you can see here, on average, female, they spend more than male. You can see this is the median, then the mean median. This is for the male. Then the lowest amount as well, I think the lowest amount is almost the same. The same thing with the first quartile. Then the maximum amount is also spent by female. We have the maximum amount for male, we can see it here. So let's try to translate this to a volume plot. So this is, it looks alike here if we follow these volume plots, but we can see that the amount here is is greater than what we have here. There are a lot of females, they spend more around this place than male. Then we have the maximum amount. Okay, we have more male here, but we have the maximum amount being spent by female. The maximum amount is for female here, but the two of them are so close. The box plots make it more clearer. You can see the line here. We have the 1,000, then we have the line here below the 1,000. So let's try to check the product line as well. What people buy most, what male customer, what they buy most, what the female buy most. SNS.com plot. Product line. We use the U parameter for gender. And our data equals to data. You can see this. Okay. So we need to, we can see that this thing is kind of messed up, clumsy. We can see that's right. So we need to make our plots bigger. So we do that with plt.figure. Then we specify the fig size. Let's say 16 by 12 by 6. 12 by 6. I think this is better. Then we can make this, we can slant them. plt dot x x6, yeah. Rotation equals to 45 degree. You can see this now. So this is better. The inference, we can name this, we can give it a title, plt.title, then plt.x and y axis. We can see that for health and beauty products, majority of them is what? Male. Is they buy more of health and beauty product than female. Then we can see from the electronics too. Male customers, they buy more of electronics than female. This year they are almost the same. The home and lifestyle, they buy almost the same almost the same quantity. Then for this one, sports and travel, female, they buy more of the products than male. And yeah, food and beverages, female buy more of the food and beverages than male. The same thing for the fashion accessories. So female buy more of it than male. But this, I find this somehow, for example, if you are giving this data that you are asked to make an assumption, you might be like, okay, female will be buying more of health and beauty products than male. Can anyone explain why we have the opposite here? Like male buying more of it than female. I'm waiting.
I think it depends on the where the data was collected. Maybe they have, I don't know,
Okay, let's
more male customers that are sick.
okay, that's true. And it can be that maybe they are buying for their family, their wives.
That's true.
For their girlfriend.
Box plots. Let's check the ratings. The ratings, the box plot for ratings. I need to specify the data type. Data equals to data. Then this will be my y-axis. I want the city to be on the x-axis. X equals to city.
That's what.
I'm not sure of the name of the column. TF data dot columns. Yes, it's rating. Okay, no S. You can see that on average, all of the three cities, all of them, they have similar rating. But on the average, Lagos and Akwa Ibom, they have a rating of 7, whereas Ibadan has a rating of 6.5. So let's check for the gender as well. Let's see who gives the best rating, male or female. Okay, on average, female, they give good rating to products than male. On average, this is 7.2. Then here we have 6.9. So another thing we can check is There are a lot of things we can check actually, a lot of them. So you can, based on what we've done now, you can make conclusion. You can write your conclusion and observation. Okay, let's say we have more female customers than male. The male buy more health and beauty products than, than females. Then you can say female gives higher rating than male on average. Then there are a lot of, you can also try to check the year with the maximum. SNS don't count plots. The year that has the maximum sales. So everything we are dealing with, it happens in 2029. So we should drop the year column. So let's check with the month. The month with the most sales.
The way you spell the month is not correct.
Thank you. So we can see here from here that we have just 3 months. The transaction, all the transaction, we have the 1,000 transactions. All of them they happen between January and March. So the most sales occurred in January, followed by March. Then we have the list in February. So this is how we make. You can add this as part of the conclusion. The most sales occurred in January. Then you can try to check the time of the transaction as well. You see what when people buy most, you can check, okay, people, what time of the day do people buy most? Is it by midnight, early in the morning, in the afternoon, then at night? Then you check who buys this particular good at this particular period of time. You can use the U parameter, you can put gender, you can put time in, and a lot of other things. So this is how these are some of the steps you can follow when you are working on a data set. Try to, before you start, write out what exactly you can write out the problem statement, the question you are trying to ask with your data. Then by the end, make sure you've provided answer to all the questions. So that's how to analyze the data. Then it's good to have an outline, something like this, a step-by-step approach. Okay, after this is what I did. After this, I did this. After this, how I did it. So that's that. Our capstone project is going to be, we are going to make use of this data, this particular data set, the one that we are working on to do our capstone project. So I'm going to draft out some questions. You will answer the question by code, then you will buttress it with plot visualization. For example, if I ask which branch point, then there are some other questions too. We are going to be providing answers to. So this is the data set we are going to be using for our visualization. So today, I just want to talk briefly about machine learning. There are some people that they showed interest in it. So machine learning is kind of is a subset of what? Okay, it's a part of the programming, where it's by the name machine learning. You make normal programming is you set your rule, then you write your code, then you see the output. Based on your code and the rule, you see the output. The machine learning is you give the system your code and the data, like the outputs. You give the system your code, then the output, then you just allow the machine, the program to generate the rule by itself. That's machine learning, for the machine to learn by itself. So the application of machine learning is known as artificial intelligence. For example, if we build a model that predicts if a transaction is going to be fraudulent or not, deploy such model into production, you are making use of it in a, let's say in a banking system. So when you deploying it, they are using it for in production. That's artificial intelligence. or you train a model, a self-driving car model to drive itself. The process you deploy it, it is working in real life. That is artificial intelligence. Or you build a model that predicts if a patient is going to have cancer or not. When you deploy such model, let's say you deploy it in a okay, for example, during the corona time, we know there are different type of thermometers. There are some thermometer once they place it on your forehead, it will start like it will change. It can change to color red or something. So those are artificial intelligence. They've built a lot of things into the model. Like maybe the part of the data they collected, the temperature, maybe the age of the person, the height, the color of the skin. I don't know. So once it is being deployed into use, that's artificial intelligence. So we have three major type of artificial intelligence. We have supervised learning, we have unsupervised learning, then we have reinforcement learning. This semi-supervised is just the combination of the first two, supervised and the unsupervised. The supervised learning is like, for example, let's say I have a student data set now. We should welcome. Okay, this is the student data. So we have, let me try and copy this. We don't, for machine learning, we don't need, this is supposed to be the surname, the first name, the last name. We don't need the name. We can make use of gender. Then we can also make use of, see, let me create a new sheet. So for supervised machine, can you still see my screen, please? Hello.
Yes.
So you can, when you want to feed this data into machine learning model, now you can change because computer doesn't understand all these character strings. So we need to change this gender. Male, you can equate male to 1, female to 0. So we can do that. After that, this is our data. Let me put this here. So this is our input variables from here to here, down to the end of the data. So this is the one that I highlighted. That's our input data. Then what we want, the output we want is this intelligence. So we want the machine to predict the kind of any relationship that leads to the level of intelligence for each of the students. Maybe it depends on their Greek score, it depends on the English score, it depends on math score. We don't know. We just give the data. We give the data to the machine. We give all this data, then we give the output as well. Then we ask the machine to learn the relationship between this thing and this thing, so that next time you give the computer, the model, a new data. For example, let's say a student with this score, a female student with this score, the model can predict the model can predict the level of intelligence for such students. This is one of the. So this is a kind of just a simple approach to the machine learning modeling. This in this data set, in this project, I used the student data set where we want to predict the level of intelligence based on the following, based on these variables. So the first thing I did, I created a new column here, the total score. Feature engineering. Okay, this is I created a new column here named total. Based on that, I first carried out a simple linear regression. Simple regression is you are using one variable to predict one variable. So that's simple linear regression. I used the total score to predict the student level of intelligence based on their total score. So I splitted my data into training set and tested. Your training set is like this. We have this data. We have like 27 data points. We can try to break this, let's say from 17. Then I can shift this downward. So you can see that. So for the training set, we can make use of this from 1 to 16. We can use them as training sets in the sense that we give the model our data, then we give the model our output as well. Then for the test set, we are going to hold the outputs. Let me delete it. So we now give this our data, we give it to the model, we've trained here, based on what the machine has learned. Based on what it has learned from this, then we give the data to use that learning to predict the level of intelligence for this set of people. Although we have the real level of intelligence, so after that we now compare the machine prediction to our real values. So that's what I did here. So for example, I for this particular one, 1, 2, 3, 4, 5, 6, 7, 8. The 8 data point I use as my test set. Then when I compare it with the actual value, the machine predicts 6.9 for this student number 8. The actual value is 6.99, then the predicted value is 7.0. The same thing for other students too. So I went ahead to do multiple linear regression. Multiple linear regression in the sense that instead of using the total score, I used the 5 subjects separately, the math, English. Then I dropped the total column. I now use the 5 subjects to predict the level of intelligence for the students. So this you can see that this is the actual value, the actual level of intelligence for the students. Then this is the predicted value. We can see that it did better than the simple linear regression. We have 6.98 here. Then the actual value is 6.99. There, the actual value is 4.67. Then the model predicted 4.65. This one, the actual value is 7.61. Then the model predicted 7.6. We can see that these values, they are so close to the actual value. The predicted value is so close to the actual value. So the real life application of, for example, if I deploy this model to monitor student performance now, I can use it to predict this it now. This is a new student that is not on the sheets. We don't have the data for the students before. So the student has a score of 24.5 in mathematics, then 17 in English, then 93 in biology, 100 in economics, 100 in agri. Then the machine predict that the level of intelligence for such students is going to be 9.2. So that is basically the how machine learning works. And we can have another one, fraud detection. We can have data such as the time of the transaction, the gender of the person that carried out the transaction, then if it is online, if it is bank, like if it is online transaction or physical transaction, then the time of transaction. Based on those variables, we can predict if a particular transaction is going to be fraudulent or not. Then we can use that one to predict cancer as well. Then we can predict the salary. For example, if we have data as the age of an employee, years of work experience, then the level of education of the person. So we can predict the salary for the person. Another thing, we can predict loan default. Loan default is to predict if someone is going to default a loan or not, simply if the person is going to pay back the loan or not. So there are some variable we need for that too. We need some credit card score, then the age of the person, the level of education of the person, and some other variable. With that, we can predict if the person is going to default loan or not. Then we have unsupervised machine learning. For example, the data we worked on today, we don't have a particular target that we want to predict. We can try to group the customers based on some trend. Maybe people that buy a particular product, we try to group them together. Let's say people that buy health and beauty products, fashion accessory, then home and lifestyle. We can group them together as one. Then electronic accessories, sport and travel, then we group them as one. Then food and beverages, another group. So with that, we have in 3 clusters. For that one, we don't have the output, we don't have the target variable. We just allow the machine to give them a kind of clustering. Then we have reinforcement learning. Reinforcement learning is like you are not programming the model explicitly, you allow the program to learn on its own. That's what they use for self-driving car. Let me use an example. For example, you train a car, and there are two things that is usually applicable. The first, like two opposite things. The first one is, if the model is doing well, there will be a kind of reward, and if the model is doing bad, there will be a kind of punishment. Let me use this as an example. For example, let's say you train a machine learning model, a self-driving car. The car is driving itself. Whenever the car, let's say the car just go and hit someone, you penalize the car. So the car will know that, okay, next time when I see someone that look like something that look like a person, I'm not supposed to hit the person. So that's a kind of punishment. The model will learn on its own based on the environment. Then when the model does something very good, maybe avoid a person and doesn't hit a person, you reward the person, you reward the model. So the model will know that, okay, this thing I just did is very good. I need to do more of it. So that's reinforcement learning. And I got this image. I think I saw it on WhatsApp. So supervised learning is you give the system the data and the output. Then you allow the system to find the rules, the relationship. Then unsupervised learning is that you don't tell the system the target variable, you just allow the machine to find it out by itself. Then we have the reinforcement learning. Reinforcement learning is learning by doing. You learn based on what you encounter in your environment. So this we can stop here. If you have one or two questions, you can ask now.
Like you talked about under this this reinforced machine learning, you talked about rewarding the model. How do you reward your model?
It's just mathematical computation. You try, for example, let's say if the model you use, let's say I'm not saying this is how it works. I'm just using that as an example. Let's say if the model does something very good, you just try to add one to the score. Then if it does something bad, you try to minus one from the score. That's a kind of reward and punishment. They are just mathematical computations.
Okay.
Do you get it? Hello.
Yes, thank you.
All right. Do you have any other question?
No, for me, I don't have any.
So our capstone project will be based on these data sets. Then the deadline will also be next week. That's making 3 projects like that. So we are going to be rounding up the class next week, inshallah.
The, consider those who are fasting now. I
No
think project
problem.
at once is too much.
The first project is not, it's just a small something small. Then the second one is not it's not a big deal as well. Then for this capstone project, we've talked about majority of what you are supposed to do. The next thing is just to provide a specific answer to the questions that I will be asked that I'll be
Okay,
asking.
sir.
Okay.
So I want us to finish the class next week.
Um, Abdul, please, do we have after this class ends, do we
Yes,
have an opportunity of reaching out to you if probably we are doing something and we need your assistance?
no
Would
problem.
you
If
be
the group will still be available, if you need anything, you can send me a DM or just post it on the group generally for everyone.
On the PA.
okay? Just to help us grow better.
Always
Thank
come
No
you.
problem. You're welcome.
for 1 hour.
So we'll be ending the class right now. See you
Session
guys.
now.
Bye bye.
Right.
You don't add us back, yeah.
Okay, yeah, here again.
I think the calls are finished.
Hello? Hey, the
The
man
calls
has
are
gone.
finished.
So added us back.
Could it be our network?
What is happening? Hello, sir. No, let me check participant.
Hello, can you hear me? Hello.
Yeah, we can hear you
Yes,
now.
we can hear you.
Okay, you said you have a question.
Yes,
Do
I
we still
wanted
have
to ask.
Wait, do we still have Mohammed Awala on the group? He was asking if you can, like, you can use 3 variables. Do we still have him on the call?
I don't know.
Okay, go ahead with your question.
Okay, I wanted to know, like, how do we know the best plot to use when we are visualizing our data?
The first thing you first consider what you are dealing with. For example, you want to compare total price as continuous variable, right? For that, you can use histogram to see the distribution of the plots, to see what majority of the people, what amount they spend as their total price. Then you can compare it with other variables. You can check it by gender, by city, by branch, then by month. Do you get? Hello? Hello?
I think they've been disconnected.
Okay. Do you have a question? Moin.
No, sir. No, sir.
All right. All right, bye. Kafila, do you have any question? I can't hear me.